People routinely select paint colors from tiny, isolated paper chips based on current aesthetic trends. A room painted without considering the occupant's biology triggers chronic, low-grade sensory stress in the nervous system. Paint is an unavoidable environmental and neurobiological intervention. Watch the impact when harsh sunlight floods a stark white, high-reflectance minimalist living room. The contrast completely blows out. This high-reflectance minimalism forces the brain to work harder. Without visual anchoring to process spatial boundaries, your cognitive load increases. Ignoring the biological function of a room turns your largest surface of sensory input into a neurological hazard. Light waves enter the eye, where the retina's rods and cones capture specific wavelengths. These electrochemical signals travel past the visual cortex and move directly into the hypothalamus and pituitary gland. These glands regulate the endocrine system. By releasing hormones into the bloodstream, they alter your body temperature, sleep patterns, and energy levels. Disharmonious color combinations physically activate the amygdala, the brain's emotional center, triggering automatic stress responses. Because 80% of our sensory impressions are visual, wall colors dictate our hormonal baseline. Spatial psychophysics uses light reflectance value, or LRV, to hack the perceived size of a room. This quadrant matrix charts LRV against the direction a room faces. Pairing high LRV cool tones with a north-facing window creates a physical problem. North-facing light naturally has a cool, gray cast. When combined with high reflectance cool paint, the environment feels sterile, clinical, and emotionally detached. However, high LRV cool tones offer a spatial benefit. Because light blues and greens recede from the eye, they trick the brain into expanding perceived boundaries by up to 19%. A contrast-free approach, painting walls, trim, and ceilings the exact same hue, completely eliminates the optical boundaries that define the room's edges. This technique demands flawless drywall finishing. Removing the optical breaks provided by trim and molding exposes every structural imperfection in the wall. Artificial lighting introduces another variable. Cool LED light, often between 4,000 and 5,000 Kelvin, ruins the appearance of warm paint tones and disrupts evening circadian rhythms. A paint color's psychological impact is never absolute. It is entirely at the mercy of the room's unchangeable physics of light. The warm spectrum, reds, oranges, and yellows, stimulates the sympathetic nervous system, increasing arousal. A bustling dinner party within a deeply saturated red dining room accelerates the energetic movement of the space. Saturated red physically increases heart rate, provokes conversation, and stimulates appetite by up to 25%. The warm spectrum induces rapid fatigue of the nervous system over prolonged periods. Intense yellows heighten activation in the prefrontal cortex. While initially optimistic, they increase cognitive agitation over time. Earthy warm tones like terracotta ground a space, providing stability, but they require specific lighting investments. Because earthy tones absorb light heavily, they require significant illumination to prevent the room from visually contracting and feeling oppressive. The warm spectrum requires a trade, exchanging long-term relaxation for a short-term spike in energetic arousal. The cool spectrum, blues, greens, and purples, activates the parasympathetic nervous system, facilitating introspection and rest. In research conducted at the University of Texas, participants in blue environments saw a 15% increase in measured work output, while green-walled offices were linked to an 18% boost in creative problem-solving. Data published in the Journal of Environmental Psychology shows that muted blues facilitate a physiological drop in heart rate, correlating with a rest average of nearly 8 hours. The functional trade-offs involve energy regulation. Cool colors can suppress morning arousal energy, making waking up difficult, and act as subtle appetite suppressants in dining areas. For neurodivergent individuals with ADHD or autism, muted, cool, and earth tones are critical tools to soothe neuropathways and lower sensory overload. This morning light filtering gently across a serene sage green study space illustrates the calming effect in real time. The cool spectrum maximizes biological regulation and cognitive focus, but inherently compromises the room's capacity for high-energy social interaction. Applying color systematically avoids the undertone surprise when a color reveals an unintended blue, pink, or green tint once on the walls. The 60-30-10 rule provides the mathematical framework for psychological harmony. 60% of the room goes to a dominant neutral, 30% to a secondary functional color, and 10% to a bold accent. Using this rule requires the discipline to remove favorite colors if they clash with the room's biological goal. Before looking at a paint sample, perform an audit of the room's primary functional purpose. Then audit the room's natural light exposure to understand the unchangeable canvas you are working with. Adhering to these disciplined color ratios prevents cognitive overload and protects the room's intended function. For the wellness optimizer, audit your Kelvin bulbs first. Use low saturation cool tones for sleep and warm mid-saturation tones for appetite regulation. For the spatial problem solver, utilize high LRV cool tones in contrast-free applications to push walls away in cramped spaces. For the neuro-accommodator, avoid high-contrast complementary schemes that spike cognitive load. Stick exclusively to analogous, muted earth or cool tones. This split-screen comparison shows the same room painted three ways: stark high LRV white, deeply saturated warm terracotta, and muted contrast-free sage green. Your walls are your largest surface of sensory input. Never choose a paint color based on aesthetics. Choose it based on the biological job you are hiring that room to perform.